Hello students. Last time we have discussed about the dimensions and special dimensions of the physical constants like the universal constant of gravitation and gas constant and Stephen's constant and so on. Now today we are going to discuss about the uses of dimensional formula. There are three uses of dimension formula. To check the formula, second is to establish the relation between physical quantities, and third is to convert any physical quantity from one unit system to another unit system. Now the first use is to check the correctness of formula. First example is, let V is equal to U plus AT. According to the dimensional law, the physical quantities which are subtracted or added which have the same dimensional formula. जैसे हम बोलें कि AT का जो डायमेंशनल फॉर्मूला होगा वो U का होगा और तभी हम इनको ऐड कर सकते हैं. We know that the dimension of V is equal to L1 T minus 1. Dimension of U is also L1 T minus 1. Dimension of AT is equal to A L1 T minus 2 into T means T1. It is also L1 T minus 1. So when we put the values of dimensions of each step, so we can say the L1 T minus 1 is equal to L1 T minus 1 plus L1 T minus 1. It means the formula is dimensionally second one. Example 2, let centripetal force F is equal to mv square upon r. The dimensional formula of F is given by m1 L1 T minus 2 is equal to m. Dimension of m is m1. Dimension of velocity is L1 T minus 1 whole square. Dimension of r is radius, so r is radius, so its dimension is L1. So we can say it will be equal to m1 L2 T minus 2 divided by L1. So the dimensional formula m1 L1 T minus 2 is equal to m1 L1 T minus 2. So given formula is dimensionally correct. Next example may be S is equal to ut plus half at square. Here S is distance, its dimension is L1, U is L1 T minus 1 into T1 plus dimension of half is not applicable because it is constant quantity. Acceleration is L1 T minus 2 into T 2 plus 2. So finally we can write L1 is equal to L1 plus L1. Formula is correct. The second use is establish the relation between physical quantities. Let centripetal force F depends upon mass of the body, radius of path and velocity. Then we know that force is proportional to mass raised to the power A, radius raised to the power B and velocity raised to the power C. This is the general pattern to establish the formula. Now F is equal to K constant, m raised to the power A, r raised to the power B, v raised to the power C. Now put the dimensions of each term. It will be m1, L1, t minus 2. Now K is constant. Dimension of mass is m1 only, A. Dimension of radius is L1 only, it is B. And dimension of velocity is L1 t minus 1 C. So m1 L1 t minus 2 is equal to K m raised to the power A, L raised to the power B plus C. L is here and also here. And in the multiplication process, indices are to be added, and t is equal to t raised to the power minus C. On comparing the RHS and LHS, first of all, the power of m, m1 equal to m0 implies, ma implies a is equal to 1. Similarly, first of t minus c is equal to t minus 2 and c is equal to 2. And third one is L raised to the power 1 is equal to L raised to the power B plus C. It is B plus C is equal to 1. We know that C is equal to 2, so B plus 2 is equal to 1 and B is equal to minus 1. So we can put the values of A, B, C in formula number 1. We can put the number 1. So we know that A equal to 1, so M1 and B equal to minus 1, that is the power of R, so R minus 1 and V is 2, C equal to 2. So we can write the formula F is equal to K M V square upon R. We know that here K is equal to 1. So F is equal to mv square upon R. This is the relation between mass, velocity and radius